About 2 years ago, I made a video documenting my change from using disposable batteries to rechargeable batteries. And I'm happy to say that in all the devices I have, like game controllers, which I have plenty of, and remotes, and just all kinds of other gadgets, everything I have has a rechargeable battery in it. I no longer throw away batteries, which means I no longer throw away money. And I've got a pretty good system about charging them and storing them, but it's not perfect. I've got different chargers for nickel metal hydride versus lithium. Sometimes I'll throw them on the charger and forget that I put them on the charger and they'll be there several days, which you're not supposed to do. So there's definitely room to improve my existing system. And that's what I'm hoping we're going to do today on this video. Hey everybody, it's Chris from FamilyGeekery, and today we're going to be checking out this Linogy Rechargeable Battery Station / System / I'm hoping game changer. And the good people at Linogy reached out, asked me if I'd like to test out their product. I said absolutely, so they sent it, and that's what we're going to do today is review this. Now, even before they contacted me, I've been seeing this advertised all over my social media. I don't know how those algorithms work, but they know exactly what kind of geeks to advertise this stuff to. And I've watched several videos on it as those advertisements would pop up, and I've been very intrigued. So let's just say I was kind of tickled when they contacted me. But basically, this is a charging unit that has 8 bays. You throw your batteries in there. It doesn't matter if they're lithium or nickel metal hydride. And it's going to determine what they are. It's going to charge them automatically, and then it's going to drop them into a bin when they're done. And it's got a neat little screen to count up how many trees that you saved in the process of using rechargeable batteries instead of throwaways. So that's what we're going to be looking at in this video. We're going to be checking out this charger. They sent us 8 AA batteries and then 4 AAA batteries, and they're all lithium. And then they asked me to go ahead and test those up against some of the other batteries that I already own. So we're going to check out the product, then we're going to put the batteries to the test, and hopefully along the way have some fun. So let's get to it. So before I even get into the product itself, the first thing I'm going to mention is the packaging. And I know the packaging has nothing to do with how good the product works, but it tells you a little bit about the company. It tells you that they care about their product, they're proud of their product, because you don't have to do this. You don't have to spend the extra money to, print this on here and have a good looking logo and lots of information on there. But they did anyways, and the packaging is great, and I do care about that stuff. But that being said, I'm going to tear into it now. Look, it even says 100% recyclable, water-based ink packaging, and plastic-free. Gotta love it. Alright, so expertly packed inside that recyclable packaging is, of course, the charger itself. And let's see what it comes with. We've got the charger, which has an e-ink screen. We're going to look at that when we start charging things and testing things out. It comes with these guys, which are little adapters to put a AAA battery in here so that it fits the AA. And I was wondering about that when I saw the videos. I didn't see any kind of spring mechanism on these, and that's a nifty way to go ahead and adapt those. And then it comes with a USB-C to USB-C cable. Now both in the packaging, which I mean this wrapping stuff that was around the charger itself, and in the instructions, it lists pretty clearly that you need to use a 5-volt 3-amp charger. Now, I will say that that's kind of leaving the customer up to a potential problem area if you don't already have one, or if you try to use one that's not compatible, that might be a problem also. But I've got lots of chargers here. I've got this desktop charger, which I'm sure will be able to figure out that this thing needs 5 volts and 3 amps. I've got some plug-in ones also. I'll test that as well. But it does say specifically in the instructions it has to be a SELV standard charger, and SELV stands for Safety Extra Low Voltage. Now, I've tested a lot of power banks and chargers and stuff like that, and I've never seen that term before. Maybe I've just overlooked it, but I'm sure one of these things that we have around here is going to work. But let's take a closer look at the charger itself. We've got the 8 slots up here that you're going to put your batteries in. We've got the drawer that comes out here that they're going to drop down into, and then just a well-built device with that e-ink screen that's going to count up how many batteries it's charged and how many kilograms of carbon dioxide or whatever CO2e is. But yeah, it's really nice, simple design, elegant, and I like the fact that we're just going to pop these in. There's no worry of overcharging them. They're going to drop down into the bin when they're done, and they're ready for us to use. So let's go ahead and plug this thing in next and pop some batteries in it and see how it works. So I took the included cable and I plugged it into the Anchor desktop charger here and got it plugged in, and yes, the thing did come to life. I double checked inside the app here that It is detecting it as 5 volts. It's only using 0.2 amps right now, but I'm sure that's going to go up once it starts charging. But so far, so good. Now, this is a 3-in-1 charger. It charges lithium-ion batteries, nickel metal hydride, and NiCad. And of course, we know the benefits of using rechargeable batteries versus using non-rechargeable batteries, how much money you save and how much waste you save, basically. But it's also good to know the differences between the lithium-ion batteries and the non-lithium batteries as far as the benefits that you get from them. Lithium batteries are going to charge faster, they're going to have a deeper state of charge, they're going to have a better power curve, and they're going to hold their power a lot longer on the shelf. And of course, if you've been around for a while, you've heard the term battery memory, and that's something that we always had to worry about. And with lithium batteries, you don't have to worry about that. So I'm going to pop some of these batteries in here. These are the Linogy Lithium AA's here. These are the Pro. They are 1.5 volts and 3,600 milliamp hours. And I'm going to pop some of those in, and then I'm going to put a couple of the AAA's in these adapters here. So let me get that set up, and I'll be right back. All right, so I've popped a couple batteries in here so far, and we got some indicator lights up here. These are blinking green so far. And we've got this far right one here that says power check. If you want to just test the status of your battery, you can pop it in there. And when I say pop it in, these things snap in super easy. Some of the other chargers I've used, you can like kind of pop them in because it's got the little metal tabs at the end that kind of grab it. And sometimes they'll pop up out of there. Sometimes they'll shift over to the left or right. This was like, no doubt, these things were popping in perfectly. So once you put these in here, it automatically checks to make sure what kind of battery it is before it starts charging it. And then once it determines and auto-detects what type of battery it is, it begins that charging. So based on what we have up here, we've got a couple different states. The blinking green means that it is charging. If it's blinking yellow, it means it's detecting the batteries. That happened so quick I didn't even see it. If it's solid green, that means the charging is complete. If it's blinking red, it means that I've accidentally put a non-rechargeable battery in there. And if it's solid red, it says the current or voltage is abnormal. Take the battery out and insert it again. Now I'm going to go ahead and let these charge up. I'm not sure what the status of them is from shipping. And I'm going to wait till they go ahead and drop down into the drawer below. And hopefully you guys didn't yell at me yet about pointing at the wrong battery. But here is USB-C 2. And now that we're charging, it does show 5 volts, about 2.4, 2.3 amps. So yeah, you definitely need to have a charger that is capable of providing that 3 amps like it asks for. But if you got one of these, you're in business. All right, so here we are. They're all down in the tray now, which means they must all be charged up. And I wasn't here to watch it, but that's kind of the whole intent of this, is to pop your batteries in there, walk away, and not have to worry about babysitting them or anything. And you can see we got something registering on the screen now. It says 7 batteries have been charged, and we got a little tree starting to sprout up there. And apparently that continues to grow the more batteries that you charge. Now, I'm not sure why it says 7 when I had 8 full batteries in there, but maybe one of them was mostly full and it didn't count that one, or maybe it just goes by how many milliamp hours that it delivers to the batteries and makes a calculation on that. Now, in addition to the screen here, it also has a QR code. I think if you push this button, it will bring us to a QR code. There it is, to scan to see our impact. So let me go ahead and scan that. And it brings you to a website that talks about how they calculate how much you're saving. And you can put in how many batteries that you use per year to calculate out, what your savings is per year and how many kilograms of carbon you can reduce over the years. So that's kind of neat. A lot of good information, which I really kind of dig, all this information about, saving the environment, or at least doing your tiny little part to get your carbon footprint down. So now that I've got some batteries charged up, it's time to charge up some of the competitors' batteries. And I've got 2 different sets here. I've got these Power Owl Pros, which are 2800 milliamp hour, and these I believe are nickel metal hydride. And then I've got Power Owl lithium batteries. These are also Power Owl Pro. These are 3000 milliwatt hours, they say, 1.5 volts. And these are going to be lithium. So I'm going to charge these up using the same charger, and then I'm going to set up some tests to see how long they all last. So let's pop these in. And we got 2 lithiums, 2 nickel metal hydrides. It's going to figure out what kind of batteries they are. It's going to charge them up, and I'll be back when they're done. All right, so I wanted to show you real quick the test setup that I have to test these batteries out for their capacity. Now I've got this power meter thing here, which will take any kind of input and it'll apply a load to it. and you can program what kind of load you want to produce, and then it will go ahead and count all the energy until you get to some kind of a cutoff voltage. Now, Linogy sent me some specs to test their batteries on, and they wanted these to be drawn at a 0.2 amp, which you can see here, constant current draw. And that orange may be a little hard to read. Let me zoom in a little bit on it. So 0.2 amp constant current draw. You can see that it's seeing this battery is, this many volts. And then once you start the test, it's going to keep on going until it reaches a cutoff voltage. And this is in purple, so it's kind of hard to read also, but the cutoff voltage is 1 volt. So it's going to draw energy out of this battery. It's going to calculate how much energy it's drawing out of it. And then once it gets to a 1 volt cutoff, it's going to stop and give us a summary screen that tells us how much power it drew from the battery and how long the test took. Now, these tests take quite some time. With only a 0.2 amp draw, the test can take anywhere from 7 to 10 hours. So I've done that over the last couple days, and I did 3 tests for each battery. Now, my original plan was to test these nickel metal hydride batteries from Power Owl, and then the Power Owl lithiums, and then the Linogy lithiums. But I'm going to demonstrate real quick on this nickel metal hydride, which is a 1.2 volt battery. Now we can see right here that as soon as I apply a load, even a small load like 0.2 amps, it draws that voltage down and it hits that 1 volt cutoff pretty quick. So I was able to get one of these tests to run on a fully charged battery for, about an hour, but that's not really fair compared to the lithium batteries that we're comparing it against. So I'm just going to go ahead and throw these nickel metal hydrides out of this test. But I did do 3 runs of each of the Power Owl lithiums and the Linogy lithiums. And because there was possible anomalies on the test, I am going to throw out the lowest result from each of the tests and then just average the high 2. So let me grab those results for you. All right, so before I show you the results, I want to introduce you to the 2 batteries that I ended up testing. So I've got a Power Owl Pro here, and this is a lithium battery. And we're looking at 1.5 volts, 3,000 milliwatt hours. So remember that number, 3,000 milliwatt hours. And then here's the Linogy, and this is a 1.5 volt also, 3,600 milliwatt hours. So they are 2 different listed capacities, but I'm going to take that into account when I show you the results. Now, because I did a test for constant current, that means that the voltage can go up and down as it's testing, but the current draw stays constant. Now, because of that, I'm going to use milliamp hours as the capacity for both of these. And to do that from a battery like this, it says how many milliwatt hours is. You just divide how many volts this battery is, and that's how you get your milliamp hours. Now, most of the time when I'm testing batteries or power banks or something like that, I want to know how many milliwatt hours are, so I'm glad that they list that. But because of this test, like I said, we're going to divide that by 1.5. So that gives us 3,000 milliamp hours. Now, in the Linogy here, it starts at 3,600. We divide that by the 1.5, and we end up with 2,400. So now remember those 2 numbers, 2,000 milliamp hours, 2,400 milliamp hours, because that's what I'm about to show you how these things compare on the chart. Now on this chart, I've got 3 things listed. I've got the average capacity, so that's how much capacity my tester was able to draw from this battery before it hit the cutoff voltage, and that's listed in milliamp hours. And that's why I converted that for you. I've got the average duration test in minutes, how long it actually drew the power out before it got to that cutoff voltage. Now, because these are 2 different listed values of batteries, it's not fair to test them up like that. It'd be like testing a Volkswagen up against a Porsche. So I've divided what the average capacity was by the advertised capacity, or what's on the label, and came up with a percentage. So on this first left column here, we see the average capacity. The Power Owl listed at 2,000 milliamp hours achieved an average of 1363.5. And then the Linogy, which is listed at 2,400 milliamp hours, tested out to an average of 2242.5. Now, if you look at that chart, you can see, yes, one battery does have more capacity than the other, and we knew that up front. But if you look at the second chart, the average duration of the test and how many minutes, this test is exactly the same, right? The difference between the 2 is exactly the same because, quite simply, the current draw was the same, so the more capacity you have, the longer it's going to last. So if you look at those 2 columns, you have a direct comparison between the 2. 409 minutes versus 672 minutes. That's just based on the capacity. Now, the third column is the one that I found the most interesting, and this is the percentage of advertised capacity. So I took the average capacity, divided it by what the label actually said on it. So in the Power Owl case, it would be 1363 divided by 2,000, and that gives me 68.2%. And then the Linogy, which averaged out to 2242.5 milliamp hours compared to that 2400 that we calculated for it, gives us a 93.4%. So yes, you are getting more capacity from the Linogy because it's listed as more, but you're also getting more because it's achieving more of its advertised rating than the Power Owl did. So I think this kind of test and this graph and this data helps us to be fair up against, multiple batteries from different capacities listed. And I'll be transparent with this whole process. After the first test, when I got the results, I emailed Linogy and I said, hey, listen, if I do this 3-test thing and I average them out, I'm going to post these results. I'm going to calculate them and post these results, whether they look good or bad for you. And to their credit, they replied back and said, go for it. We appreciate your honesty. So that tells me that Linogy had enough confidence in their product to let me go ahead and do these tests and post these results. And it just so happens that it came out in their favor. So now that I've reviewed the product and I've tested out the batteries, I can honestly tell you that I'm a big fan of this thing. Ever since I saw it advertised on my feed, I thought, what a novel design. Throw the batteries up top here. Once they're charged, they're going to drop down below and store for me. I don't have to come back hours later and pop them all out so that they don't overcharge. And the fact that it will charge either type of battery, whether it's nickel metal hydride, NiCad, or lithium, I don't have to think about what charger I'm going to throw these batteries in anymore. I just pop them in here and it takes care of it for me. So you can see based on my little screen here that I have been using this throughout these tests, charging up batteries, testing them, and charging them back up. And I'm excited to watch this number grow. I think it's really neat. It's a neat concept and it's a great product. So thank you again to Linogy for sending me this product to review. Thank you for allowing me to be honest in the review, regardless of the results. If you want some more information about this, I'll leave some links down in the description below. I hope you got something out of this video. I hope it was interesting or educational or entertaining. If it was, I appreciate a thumbs up. That helps out the channel. Speaking of the channel, check out the rest of the channel for other nifty reviews and tests. I've got all kinds of geeky stuff on there, thus the name Family Geekery. But that's going to wrap it up for this video. Again, thank you to Linogy. Thank you for watching. And until next time, peace out and geek out.